Welcome to Study Loop.
5,000 kilogram satellite in orbit above Mars, initially at an orbital height of 2,000 kilometers, so 2 times 10 to the 6 meters. And then it moves to a height of 4 times 10 to the 6 meters, and we want to know how much work is needed to do that. So we'll set this up with conservation of energy. So we have, or we'll start all the way from the beginning. So the initial energy plus the work we need to do should equal the final energy. And so our initial energy is the potential plus the initial kinetic, and we have our work, and then that should equal the final potential plus the final kinetic. So we could do this by writing the potential energy in the normal way, and then writing kinetic energy as 1/2 mv squared, and then using the fact that it's a circular orbit to find v. But we can use a trick here, which is that for circular orbits, the kinetic energy is always equal to negative 1/2 of the potential at a given orbit. So that tells us then for the initial energy, we have Ke initial equals negative 1/2 U initial, and for the final energy, Ke final equals negative 1/2 of U final. So we'll apply that to the equation. That'll just save us a little bit of time. Though doing this just with 1/2 mv squared would work fine as well. So our initial energy then, and now minus 1/2 U initial for the kinetic term, plus work, equals U final, and then minus 1/2 U final. So we want to solve for work. So we have work equals, this should just be 1/2 U final, and then these terms here are just 1/2 U initial, so we subtract that, minus 1/2 U initial. And so we should get then 1/2. We know all of these potential terms are going to have a g times mass of Mars times mass of the satellite, and then we'll be left with 1 over our final minus 1 over our initial. So then all we need to do, we'll come over here, is now we can write those radiuses as the r final should be the radius of Mars plus that final height, and then we have minus 1 over our initial, which is again radius of Mars plus h initial. So we'll have to look up the value for the mass of Mars, then radius of Mars. But we have this expression, and then when we evaluate that, we should get 5.36 times 10 to the 9th joules.